Welcome back to Database Fundamentals. This is Module 2 of Database Fundamentals, and it is about relational concepts. In this module, we're going to talk about referential integrity and normalization, which is another big topic.
One, definitely.
That's right. And I think we're going to get into a couple of other small topics around constraints.
I think we should. We're probably going to introduce constraints at this point, so we have an idea as to how they'll help with the referential integrity piece of it.
But this is Module 2 of a 5-module course. If you've skipped Module 1, we talked about some of the core concepts about databases. And we'll be going on into other fireworks demos later on about how you create objects in your database and how you get information in and out of your database, and then a little bit about administration of your database. But now we're going to get into some of the relational concepts. So not quite data modeling yet, but we're going to talk about sort of the concepts that are the fundamental pieces you'd need to know before you can actually go and create a database.
Well, you brought up a good point in the previous session where we talked about the idea of data modeling. So this really focuses on that aspect of data modeling in the sense that, okay, I've got my ginormous Excel spreadsheet. You guys have got me convinced I want to move it into Access or SQL Server. How do I go about doing that? Well, how do I decide what do I take into consideration when I'm actually going to design that model that I'm going to use inside a SQL Server or Access? So what we're going to talk about here is what's called normalization, and we're going to look at what referential integrity and constraints, pretty much what we've already discussed here. So the idea of normalization is really it helps us decide how we're going to build our tables out for our content. What this does for us is it allows us to use a strategy that's been designed to determine what content is going to be stored where. So normalization is the process of organizing that data in a database within tables and establishing relationships between those tables. We hinted to that in the previous session. The process is used to also help eliminate redundant data. So if we go back to our DVDs, we had talked about that we have hundreds of DVDs, and if we have a genre of jazz, I might have that title in there 50 times, 500 times. It depends how many DVDs I have that are jazz related. So the idea of that is just kind of a little bit overwhelming. So if you look at a spreadsheet that's got thousands of rows and 30, 40, 50 columns across, if you look at it, you're going to look and see a lot of redundancy. And one of the things that helps with normalization, or normalization helps with, I should say, is the fact that we can eliminate that redundancy. By default, there's 5 normalization forms, as you can see here. One is eliminating repeating groups, all right? Eliminating redundant data is number 2. And the third level is eliminate columns that are not dependent on the key. We'll introduce what that means in just a little bit. 4 and 5 are isolated independent multiple relationships and semantically related multiple relationships. We're not going to drill into those at all. I just want to show you out there, if you look up normalization, you're going to see 5 levels. Most databases are designed to 3, and that's what we're going to focus on here.
So in the first module we talked about, we're not going to talk about data modeling. And now you're showing me that there are 5 normal forms of normalization, and we're going to talk about just the first couple of them. So this is another, this is a huge school of thought around what normalization means, and you go really, really academic, but we're going to keep it simple and talk about those first couple.
Yes.
But it's another opportunity for further study.
Yeah, this could be hours and a whole entire class.
I bet you could talk about normalization for like 3 days.
Exactly. All right, so first normalization. How do we work with our content? The first normal form means the data is in an entity format, which means all of these conditions have been met. We've eliminated any repeating groups. And by the way, we have an example of this. So you're going to see this with okay, it looks good in print and text, but what does this mean? Well, we're going to demonstrate this for you. Create a separate table for each set of related data. Boy, we talked about that with our CDs, how we're going to create a table that are, instead of having them stored in Excel, we're going to create a table for, for our artists and maybe for the genres and for the different types of tables. And then we need to kind of tie those together, and we're going to identify each set of data within the table. We're going to tie that using what's called a primary key, and we're going to introduce that as well. We're not going to use multiple fields in a single table to store similar data. That's pretty much what a spreadsheet does for us. We don't want to do that. We want to avoid that. So we're going to set up this relationships between the tables to allow us to create that. And we do this with, this is just introducing the first normal form. Our second normal form ensures each attribute or each column describes the entity. So again, if we go back to our CD is going to be, we're going to have a row for CDs. We want to make sure that every entity or every column in there is directly associated with that CD. So it's going to, and we're going to actually tie these tables together. We're going to be able to reference one table or CD table to our genera table by using what's called a foreign key. And again, I promise you we'll show you what that means here. Records should not depend on anything other than the primary key that's in that row or that table. And again, we'll expand on that. And we can create what are called composite keys. Composite keys, in order to make something unique, I may have to use multiple columns. So we could, and we'll explain that as well. So we could create what's called composite keys to make sure that we have the uniqueness in those rows. Third normal form checks for what are called transitive dependencies. They eliminate fields that do not depend on that key. So I might have extraneous information in there that's not relevant, and I want to put that in a separate table. So I may do that, and as part of the third normalization of the third normal form, when I'm massaging that data to make sure it's all in that third normal form, we're going to make sure there's no columns in there that aren't directly related to that CD. All right, and again, we'll show you that here. In general, if the contents of a group of fields apply to more than a single record, those require a separate table. So again, just conceptually, all right, Brian, you've got me convinced that we want to take our CDs and we want to put them take them out of a spreadsheet, put them in a database. How do I do that? So we're going to look at how we're going to address that using this third normal form. As I said, there's a couple other ones. There's a fourth normal form called, BCNF, so I don't have to try to pronounce the names. We're not even going to worry about those. There's a slight risk of not having the perfect design, but it shouldn't affect the functionality if we don't implement fourth and fifth normal forms. And that's why we're not even going to address those at this point here. All right, let's take out this table here. This table here is kind of like a spreadsheet at this point, but we've got unnormalized table. We've got a table here that has student number, to be more precise, advisor, the advisor's room number, where we can find that individual. And then for student 1022, they have a class 101-07, class number 2 is 143-01, 159-02. This is an unnormalized table at this point. So what we're going to do is over the next few slides, we're going to take that content and we're going to normalize that content. We're going to implement first normal form first, then second, and then third, and you'll see what we have for a result of that. Well, if you remember correctly, the first normal form, as it says here, is no repeating groups should be in that table. So notice what we've done here. We've taken class 1, 2, and 3, which is a repeating entity, and our group, and what we've done is that now we're going to have student. So now we have student 3 times. We have student 1022 with the same advisor, with the same advisor room, and the same class number. So you can see we got rid of the repeating groups, but now we've got some redundancy. We're going to address that in the next normal form, in the second normal form. So we've taken our unnormalized data and we've added some additional rows to it, and we've consolidated the number of columns that are in this table. All right, so we've taken that content and we now have no repeating groups because we've applied the first normal form process. Now, as we move into the second normal form, we're going to eliminate redundant data. So now what we've introduced, we've taken that one table and we've created 2 tables. The table now is called students. So for student 1022, his advisor or her advisor is Jones, and that advisor can be found in room 412. Student 4123 has a different advisor. She can be found in room 216. So that's a separate table. Now if we go to registrations, because we can't just drop the information about the registrations, we created a second table for the student number. Student number 1022 is going to be attending class 101-07, as well as 143-01, as well as 159-02. That's a pretty light load, don't you think? Only 3 classes? Come on, dude, don't be a slacker here. Anyway, and then student number 4123 also taking 3 classes. So we've taken the content, we've split them out now after first normal form. We've introduced a second table that's going to allow us to avoid or eliminate that redundant data. Let's take it to our next level, our third normal form. Eliminate data not dependent on the key. Let me go back just 1 second here. We're going to see here that in the student we have 1022, we have with the class number, but we have multiple rows, and you can see the students, that was under registration, excuse me. The students, we have student advisor and advisor's room. So if we go to our third normal form, we've got faculty. We've got student number 1022. Their advisor is Jones. Now remember, if I go back, I'm going to flip back one more time. When I look at this, I've got student number, I've got Jones, and I've got the advisor's room is 412. Well, the main item, or the main column in here is student number. That advisor room is not directly associated with the student number, so it does not belong there if we're going to normalize our content. Hence, what we do here is we introduce a third table. Now we're going to have a student, my rows are off a little bit, we're going to have our student, which is 10022, their advisor is Jones. Now I want to figure out where's Jones, where the room number is for Jones. I'm going to jump over to the table called faculty, and that faculty table is going to have the room number, and also we're going to include some additional information about Mr. Jones, and that's the department number that they belong to. All right, so again, no redundancy, and every table or every row in both these tables so far are directly associated with student number. So we've got student number, the direct association advisor. The advisor, the direct association is the room number and the department number. Now we go to our registrations table and we have student number 1022. That's going to be attending class 101-07. 1022 will also be attending 143-01, and as you can see, it rolls down that way. So we've applied the third normal form by looking at these, because now we have our student number as one table, and it's mapping to the faculty table using this advisor name, and it's also mapping to a student table using the student name. So we've taken this spreadsheet, or this unnormalized table, and then we've created 3 different tables out, and we've applied the third normal form. First normal form, second normal form, and third normal form to get that to what's called third normal form in the normalization process.
You may have just blown my mind a little bit. Can we go back a couple
absolutely.
of slides and look at the original?
Right back here. So here's our
That's
original.
right.
Yeah.
So I just want to just talk through that one more time.
Okay.
We've got student information, we've got the advisor information, we've got the advisor's room, and we've got the schedule for each student in one table. That's the unnormalized table on this slide.
Yes.
And you just kind of took us through the 3 levels of normalization, and we ended up with a student table, an advisor table. Can you go on to the next slide there?
And then so we end up
a
with
registration table. Right, so the student, the faculty, and the registration. So we took that one unnormalized sort of spreadsheet-like table.
Yeah, exactly, yeah.
And you broke it up using these basic principles of normalization into 3 discrete entities of information. And just summarize that for me. So we went from one big table to 3 different ones. Why is that going to be valuable to me in my database?
Well, when we see it, so what now when we start retrieving this content, so first off, we're not going to have a bunch of, if we go back to our CDs, we're not going to have a bunch of jazz in there 100,000 times or 50 times. We're going to eliminate a lot of redundant data. So now, if I normalized an Excel spreadsheet at 1,000 rows and 80 columns and was able to normalize it in database tables, I'm going to have less data because it's going to be stored in there, because I'm not going to have jazz in there 500 times. I'm going to have jazz in there once. It's going to be a one table one time, and I'm going to reference that table. Every time I have a CD in there, I'm going to reference that table and say, yeah, jazz associates to, general ID 123, and I'll reference that. So I'm actually creating a cleaner environment, less redundant data, and all my columns that are associated or within a table, the new tables, are all relevant to each other. They're all associated with that primary column. We're going to talk about that, what that means in just a few moments. We've already introduced the term, the primary key, and we're going to actually roll that out and show you how we do that in just a few moments here. So we've kind of cleaned it up. We've got more tables, so you think, wow, I went from one table to 3, but now when I get ready to retrieve it, when you get module 4, and I want to be able to slice and dice this information, it's going to be so much easier for us to do so than what we could do in an unnormalized data
Great.
table.
Okay. Thanks. Yeah, that looks really good.
Great, thanks.